Yeah, you ready for this? Okay, cool. So, oh, nice. Everyone here. Hello, all your faces. All right, cool. So I'll start off with a few slides just to kind of like get everyone on the same page and do like, what's an XSS? Why are we talking about this and all of this stuff? So let me go through this really quickly, just to go to the slide. So yeah, so I know we're talking about React security and like what kind of like, is this going to be another talk about XSS? Like, why are we even talking about XSS or cross-site scripting in 2021 when we have React? So I know you're all saying this. And so kind of my next slide is kind of like, hello, XSS, my old friend, because people are doing weird things when it comes to the web, even when they're using React, Vue, Angular, all the modern stuff that you might be thinking of, they're doing weird things. If you didn't kind of catch what's going on weird with this, I've got a slide that highlights it. You could see that some people are like using the use effect, whatever hooks in React that it has, but they're actually using the native DOM API, the inner HTML one, to take a count variable and push it in. And that's kind of like, what happens when that count variable is user controlled, where is it coming from, all of those kind of stuff. So things go bad, right? So this is just one example. Very recent, I was like looking on Twitter what people are actually sharing, and like this came up. I try to like not shame anyone, so I think of if I remember correctly, I can like change the name that you're saying for the Twitter user. But anyway, this is another one, right? Like this is these are people trying to avoid evil, which were actually I was sharing on Twitter the other day, and it's not a this is not a good way of doing it either. The idea here is someone is actually trying to avoid evil, but they're actually still passing user input, A plus B, whatever A and B are, to this function. So it might seem like a good idea. It's not a good idea to do this because A is still runnable, whatever I do there. So if I change that with a function like IAFE or something like that, that's still gonna run. That has the context. So that's kind of like why I'm kind of like, this is the intro, right? This is XSS is mostly secure by default if you're using React, but that's why I'm going to say mostly. The thing is, I know that it's catching some people by surprise a bit because, hey, what are you talking about exactly? I thought that React is secure, so what do I actually need to worry about? And to understand what we need to worry about, we kind of need to understand what does secure by default mean when we talk about React and modern front-end frameworks. So to do that, I'll do a short introduction to cross-site scripting to make sure everyone are aligned on this topic. So first off, if we have this kind of code base where you are returning some kind of like string like this, like span first name, and then first name is a variable. Now that variable can come from anywhere, right? Like I could have my Twitter first name, have Liran something in it, but I can also try and inject some JavaScript code. So like when you take that first name and somehow puts it on a web page, maybe it would get evaluated. So if I do something like that and I'm trying to like do a script alert or whatever other XSS payload you would try to put in there, what would be the outcome of something like this? So if I do something like that, and that's like a more in the code, like you'll see that the web page, if you render this with React, it actually says script alert. Like it kind of like it looks like it's plain texting it in some way. What happens there? This is kind of like the technical stuff that we need to understand. Is the fact is when we put it like that, it looks like these are triangles, angle brackets going to the left and to the right. But not exactly. What's happening behind the scene is React is converting all of this potentially dangerous input, like those angled brackets, into what's called an HTML entity, a representation of having that angled bracket. So when the browser sees it, they can actually turn that less than whatever symbols, those HTML entities, into what you actually see. Now, that is what we need to understand. This is the basic stuff. This is basically saying in the security lingo, this is output encoding. This is a secure way to actually put information into the browser, into the page, into the DOM, whatever you want to look at it, and have it not render, not actually evaluate any real-time stuff. So when we say React is secure by default, we actually mean that React by default performs some kind of output encoding and user input. Now it is, as we said, it's React is secure by default, so, right? It's mostly secure. So what do we actually need to worry about? And what is left for us to protect in a sense? So, after we've gone, through the whole basic stuff, let's do a bit of realistic examples and some live coding. So this is just a slide to get us running, but go back into the code. Hopefully you can see those. Let me also see your face. Yes, okay, so you can see these things. So this is going to be our website, and this is all React based. It's just a live website. So what I'm going to do next is, there's a lot of stuff that we could interact with here. There's like a Twitter link, all of those kind of stuff. Let's start off with a basic. Let's say that, it's pulling all of this stuff from database. So all this information that is showing up, like, Kate Libby is this open source package profile person. So this is, should I maybe zoom in a bit more? Let's see if, okay, hopefully that's more readable. A bit more. I think that's a bit better. Yeah, okay, cool. Thanks. So let's see what we have here. So we have this database here on the right. It's going to be easier to just change some of the values. So I'm going to check for author name, and I'm going to look for it here. And it looks like this comes from over here. And, we don't need to get through the whole code base for React, just the important stuff here. And so I might be able to change this to something that might trigger an XSS, a cross-site scripting vulnerability. So I might do something like this. Image source, these are easier than the script tags because usually it just gets interpreted when it's on the DOM. No matter where it's put, and the ordering and all of those things, that's not going to exist. The EX URL. So when I had an error handler, something like this, it will just pop a new alert. So if I save it, go back here, refresh it quickly, and let's see what's going to happen. So as you can see, Kate Levy's name has just been changed to something else, but we don't see any actual issues here, right? There's no problems in terms of an XSS. The alert did not go up. And this is basically what we made. Like if I were now to open DevTools and show it to you, you'll see that this has basically been output encoded into the HTML entities. So this is the normal way of React basically protecting us. Just having a JSX variable there, and it's going to output encoded. So this looks fine. I'll go ahead and save that in my the payloader. So we could change some other things, like we could change the description about the author or whatever we wanted. But let's do some other things. Like we see that there is a Twitter link, and links are interesting because we can maybe change them to different, have different attributes on them with different values. So if I went ahead and right now it's this Twitter account. If I go back here, you'll see, of course, reload it. Yeah, so we could see that actually. Kate Libby, and now if I click on it, it's I don't know if you see it on the bottom left, but it goes to the Twitter. That's good. So my classic way of trying to inject anything here would be JavaScript Alert. Okay, let's see if I do that, what happens. It's already reloaded in the background, so you could see now it's changed to JavaScript Alert. If I click on it, this is where we have an XSS. Okay, so this is one of those places where doing things with React is not secure by default. It is not taking care of everything that you need, right? So this is where you actually want to do maybe some filtering, maybe some ideation of like what exactly goes in and where exactly is it at. Notice that specifically it's coming on the, if you go back here, on the href attribute, right? So attributes are not, to my knowledge, in any recent versions of React, are not getting output encoded in a secure way. So you have to take care of whatever you put here. So if you're building a website like Twitter, like Facebook, whatever, Instagram, all of those places where they ask you to put a social media link, your blog website, whatever you're building, and your user is going to give you a link. That link might actually not be something that you want to trust, because that could actually end up as being an XSS into the website. So even using React just like this and adding the link as the value for the href attribute, that's going to be a default security vulnerability for you. So let's try and fix this one, and let's try and do different things. So if we wanted to fix it, what would we be able to do? So we'll go a bit back here. And let's see if we wanted to maybe, like that it's already suggesting a few things here. Let's say that we wanted to, I don't know, make it just filter out all the JavaScript links, right? Because theoretically, it's possible to just have, maybe my Twitter link is something like this, or my Twitter like username or something, right? JavaScript alert. So maybe I just want to check for anything that starts with JavaScript, and the rest are fine. So potentially, one of my fixes could be just changing it, finding whatever starts with JavaScript and changing it. So I'll do something. That's the GitHub Copiloter is. I'll go with something like this. Let's say link, and then there we go. It's pretty awesome. Database.Twitter link. There we go. Okay, and then maybe let's put this into something like this. It's getting too funky here. There we go. What I want to do next is then maybe use the index of kind of function, so I can try and remove whatever happens to it. So I'll do something like if Twitter. Position 0 equals 0. That looks fine. I think this is. Now we want to do something a little bit different maybe here. Maybe like make it. Try something like that. Right, so and I've got people on the call as well. So what everyone here think about is this reasonable to do? Should we go ahead and try this one?
I was just thinking maybe there's some encoding trick. But then at the same time, if we encode some of the characters, that might break some links. So it's tricky.
Okay, so I can. It's a good point. Let's see if we can trick it afterwards. I even try to be maybe a bit more JavaScript, a bit more kind of like picky to make sure that we're actually finding only those that are JavaScript kind of like links in the hrefs and nothing else. I think that should work. Let me now update this value. Be just a Twitter link, and let's see if we didn't screw up anything else here. Refresh just in case. So,
yep.
Yeah, but that's right. I kept that as this one. But this looks nice. This looks like it's working. So generally speaking, you could push this to production, and there we go. There's no XSS. Except what happens if someone does something as simple as just use uppercase. Right, the moment you do something like that, let's see if it. I don't think it changed anything. So if you do just the uppercase, now because our matching doesn't really work for that, we get an XSS. So we haven't really fixed it too good. And then I could go with something like having actual control characters, like was suggested. So I could try and trick this in another way. Like maybe I add new line, carriage return. Let's see if I can add something like the end of message kind of link. So actually, you know what? Let's see if we fix it. Just thinking to lower case. Is that the one?
Mm-hmm.
Bit like that. Okay. Yeah, did it refresh? I think not. There we go. Okay, so this does fix it. Okay, so the lowercase does fix this issue. But then we said maybe there's control characters like x910. So this is hexadecimal code that actually represents unprintable characters, usually used as control characters that says, let's do a new line feed, carriage return, end of message, different kind of, a tab or whatever. So I can go ahead and do it, and I could, looks like it's JavaScript. There we go. Okay, so let's try this and see what happens. Okay, so even doing the lowercase, even trying to match the JavaScript doesn't work if I have a control character. So that's kind of like me trying to, prove the point, step by step, that trying to actually do anything that's like validating towards an allow list, like you're trying to check what does work, or actually in the other way around, like trying to block specific issues, is a problem. Like that's usually not what you want to do. That's kind of like the last thing in a priority. And I'm seeing a question coming in. Maybe just verify that the stream starts with HTTPS and reject if it doesn't. Right. That's kind of like where you would want to go with this. You probably want to make sure that you're actually starting with a valid protocol that you allow, like a protocol scheme like HTTPS or whatever you're supposed to do in that link. But that's probably what you want to do, right? Still, like know that those href, like the proper way to mitigate them is to have URL encoding into that area. Okay, that's kind of like the proper way of doing that. Just like you have output encoding, you want to do URL encoding in that specific area. So what do you think so far? Like React isn't so secure by default, is it? Have to take care of some stuff.
Yeah, I guess the question is why don't they do encoding in this case by default?
It's a good question. We've had some Twitter exchanges on that one. I'm pretty sure that I remember in memory that one version definitely went out a couple of years back that fixed it. But I think it may have added regressions or may have broken some deployment. I'm not sure on that, so like don't catch me on my word, but I vaguely remember that they had fixed it. And so they have actually now like changed it back to not do anything. So any recent version, and I'm pretty sure I have recent version of React here, and they just don't do that by default. So like 7.10 something, that's should be pretty recent. And yeah, like that doesn't happen by default. So you have to take care of those things. Cool. So let's see some other stuff. I've got, I do have maybe one more demo, and we have time for it. So yeah, we can go through that one. So one of the other things I was thinking is, this is kind of like a web page. If you would imagine, what creatively what this would be, it's like open source package profile. So like there's a package author, Kate Libby is here, testimonials. You could give her some props. There's a lot of issues here that have vulnerabilities in them, but we're not going to have the time to go through all of them. But the next one I think might be a fun one. And this is like package JSON that I actually want to show, like that. Imagine this like the npm JS thing, package page for whatever you want to show off. So it actually shows off the package JSON, which I think is actually handy because you could see ahead of time what scripts actually exist in whatever package you want to use. So, me being me, and I think I'm pretty having the same similar kind of nature as many JavaScript developers. I'm not going to go ahead and do this whole parsing of JSON and prettifying it like with different indentation and things on my own. I'm going to use a package that does that. So to do this, this is, let's just go through some of the stuff. And yeah, I'll go through the takeaways afterwards. But for the packages, and what I want to do is use a package for it. So I found that there's apparently a package called React JSON Pre, which is not surprising because there's probably a package for everything in NPM. So obviously there's going to be one for that. So it's like 3 easy steps, like super easy. 1, NPM install it. Secondly, require it, right? That's kind of like, that's it. Once you import it, it's there. So I've basically built this package parser kind of a small component that props it up. And there we go. I have it. I pass the props as my package JSON file that I read, and that's it. And it works. Like if we go back to the code, this is my package manifest. Imagine like this is from the database again or whatever. And I have this package parser thing here, which I showed you the actual component in the code before, and just pass it along. Basically just pass this JSON over there. So what would be the first thing that you would think of doing if you wanted to do something like this and maybe inject some JavaScript into it? Like what would be the XSS way of doing it?
I mean, you have the properties. You can always try to inject something in this package, the package manifest itself. But then, yeah, maybe you have to escape something or something like that.
Exactly. I could take the name of the package here, right, which shows up here. So I could take that one and just inject something into it, just like we did before. I think I did. Okay, not anymore in my clipboard, but I could do something like this again. Error equals alert. Is saved? Yeah, I think so. It should auto render, but yeah, no need for a hard refresh here. This so it looks like it's actually I don't know. I could look at the actual code, and it looks like it might be even encoding it correctly. Like that's kind of like what it looks like it's doing. So that didn't work. What else would you want to try and go for? Okay, so the next stuff aren't like the next step is not something that we would change here, but it's interesting to figure out like what's going on there. And maybe I'll do that. I'll do the exercise, and then we can look at the package and what actually happens inside it. So we could try different, whatever I had written there. We could try different fields, because sometimes you could try and figure out, put yourself in the mind of maybe the attacker or the developer and think, what could have gone wrong. Like, for example, maybe like whatever encoding is happening here doesn't happen in like nested fields, right? Like maybe they're not doing that function logic recursively. So you could try changing other fields, just as an example. Doesn't work, I think. It's so slow to render. It doesn't work yet. So that's not the issue that we have there. But if I am able to, create like, assume that this is package.json, right? That's the file. But if I'm able to just say, hey, my package.json is actually this. And I'll just put even a string or something. If that works. There we go. Should I actually reload this one? Let's see. That works. Okay, so you can see what's happening now. So I've actually, I needed to reload the page, but you see that now I do have the XSS working. And this is basically, and you can see like the broken image here, and you can see like exactly why it's happening and the component that actually related to it and all of this stuff. And this is happening just because I've basically replaced the content of the package JSON with something else. Now, this is still interesting because this is not circumventing anything React related to the extent. It's just a different type that it doesn't know how to handle correctly. So if we go back into the package itself, like if we go to what was this? React JSON pretty. React JSON pretty. Go to the sources, go to JSON pretty, make this maybe a little bit bigger so everyone can see it. So this is the source code for that one, right? And I didn't want to write any of this from default, so I probably would have used this. I've actually would have used this package. And you can see that it has this component, prop types, whatever, I don't care. It has this rendering. And at the end of the day, it has this dangerously set inner HTML, right? So like it needs to do some kind of styling. Now, I'm pretty sure to say that, not everyone are going to go and code review every single component that they get and install. Plus, if you do, that's pretty great. But that component can actually import and install new other dependencies. So like that's kind of, the endless kind of like, nonsense into it that, you don't really know what you're actually looking at. And you could see that it's actually having this when it calls dangerously set inner HTML, which is hopefully that's clear for everyone. It actually calls in pretty, and pretty is an internal method that actually does try right? It does try to go ahead and do output encoding where needed in different places. But specifically, the problem that it feels like the fact that we actually had a vulnerability in this case is due to the fact that this is the latest code base. But I've used a version which is like a couple of versions before, where for the error handling, which is somewhere over here, right? It returned this dangerously set inner HTML, and it didn't actually escape it. So you see this XSS object that actually returns. This line of code in the source code did not exist before in the vulnerable version, which is what I had, right? And that is why I have the vulnerability. So if you think about it, like all the happy cases, like in testing, would work well. Like you would never get an XSS anywhere here. But if someone was able to, somehow deliberately be able to give you a malformed package JSON, which doesn't exist, which doesn't have an object in it, but actually a string that would be, any sort of like valid HTML or JavaScript into the page, that is where you would actually have the vulnerability. And you could imagine, like, I can go ahead now, create a package, just a dummy package on NPM, publish it, and have my README for it. Have my GitHub repository for that package.json have this exact string, right? This malicious string, have it there, and that's it. Like, if there's some kind of system that I'm working with that isn't actually validating it, or it's just using it and bringing it into some component, like UI component like this one, then it's basically a bit of game over, because like there's no validation, nothing happens, and the fact that that person or that system actually I would say kind of like have the dependency on something like this React JSON pretty, which could have something wrong in it, like that one. That's kind of like the bummer case. So this is something to kind of like also that you would want to worry about, and I think we'll probably close it with that. And
So we have time for one more demonstration if you have, but we don't have to do it. It's up to you.
I think I'm pretty good on the demo side, but I do want to.
So we can wrap up if you want. Cool.
Yeah. So I mean, some of this stuff is React library, dangerously set inner HTML. Know about this stuff. Know that even if you're writing secure code, other people may not, and that's an issue. At the very least, avoid dangerously set inner HTML. And just have that idea that you're using components, and it might be a good idea to track them. Now, the way to track them might be, if you'd think about it, like to do npm audit and figure out, hey, I'm going to find all of those issues. That's not always going to work out, simply because npm is a great tool, but it doesn't have always all the up-to-date security data in it. So if I go back here, right, and I'm using here React package JSON for this React project, which is what is it? Okay, so this is the vulnerable version, right? 2.0.0, and if I've done an npm audit, that would have been, generally speaking, a good way of finding, if I have issues in it. But like we said, like this may not be the best source of data in terms of vulnerabilities. So I can scroll up and show you one by one what it did find, and there are like different issues here, of course. But none of them actually mentions React JSON pretty. So I might be actually having this vulnerability and not even knowing about it. And so if you're using other tools, like Sneak is one of them, but others as well, you could try and getting them to maybe try and finding those vulnerabilities, and maybe something with a little bit more kind of like security updated security database, so you could actually find the issues and mitigate them. Because realistically, none of us is actually going to code review the code for each package plus each version and each dependency that it actually adds. So having something that actually finds some of these issues, like this one, which is very much on the Sneak database, that's useful. That's useful to know where is it coming from, which version is actually fixing it, which GitHub commit actually fixed it, and so on and so on. So that's kind of like going to be my my closing here. Just use tool that actually is able to find them. And I think this is it. Like, if there's any questions on some of the APIs, I'm happy to take them.
Yeah. Thank you so much, Liran. That was a great talk. I learned a lot. Honestly, I didn't know a lot of these like tricks, which is good that I know them now, because now I can prevent them. Exactly, that's the point, right?
Awesome. Yeah, definitely.
If anyone has any questions, please drop them off in the chat, and Liran can go over some of them. For now, what I wanted to ask you is about one problem that I've had trying to use NPM audit is the pollution of it. Like, there are a lot of things that actually don't matter in general, things that are very low severity and stuff like that. How do you deal with that with SNCC? Do you think you found a better way of like not polluting the screen of the person because it's just so much?
Yeah, that's a great question. So I think part of it is so npm audit, when you run it, it will run on all of your dependencies, also the dev dependencies. As many of those, like prototype pollution, regular expression, denial of service, many of those kind of like I would say vulnerabilities you could ignore are happening on those dev dependencies. And so, if you do an npm audit minus production, that's gonna only look at the production dependencies, and that's what SNCC does by default. So if you do SNCC test, it assumes it's gonna look only at the production dependencies just by default, and so it will give you less noise. It happens. It works a little bit. I would say not so good in general, both npm audit and SNCC in that sense on Create React app projects, because the React scripts library, which builds and brings a lot of dependencies, is actually part of the dependencies and not the dev dependencies. So you're anyway going to get all of those. Yeah, so that's been the pain. But there are other ways of figuring this stuff out. And I think one of the nice outputs that we see from with the SNCC CLI is that it gives you a line and what to upgrade, and I think there's a bit more noise with other tooling, so it's just a little bit harder to reason about.
Yeah, the fact that it's just this gigantic billboard in front of you, and
exactly.
A lot of the times it also doesn't have upgrading. Like, it doesn't tell you what to do; it just tells you there's a problem, which is like, thank you, and now you have to go on this journey to find out how you can actually fix the problem. Do you know anything that could be a Sorry, go.
Yeah, go ahead. I go after you.
Could dev dependencies ever actually be a problem, like in terms of security?
Yeah.
I mean, unless you install them, I'm assuming that you just, unless crypto mining. I'm removing crypto mining from this.
Yeah, I mean, I would generally think that you probably never want to leave anything open for someone to have a way in. So if it's easier to just upgrade, it's better to have that one. But yeah, if there's a dev dependency in, I don't know, Jest, there's a Redis or whatever, it's probably not going to be anything that someone could exploit in the production application. They might target you as a developer based on that, but that would be a longer escalation of attack rather than targeting the production instance or whatever, because you're not actually shipping a testing framework to the code base. So that's why by default we ignore them at SNCC, and I think other tooling will probably start moving into similar default, just reduce the noise level for developers.
Yeah. So what I wanted to ask, I mean, now we found these issues because you know what to inject and you knew where to inject. Are there tools for JavaScript that can do the same for you? So you will be fuzzing the surface of the application somehow, that it's throwing these different strings at different places and trying to break things. Because this kind of thing, it can just keep on running for a while and test with alerts and this kind of things what you did manually.
Yeah. So there are two ways, there are two methodologies in the security space of doing that. One is static application security scanners, and that is basically the ability to understand the code base. Basically, it's static analysis. You look at the first import, look at what it's calling, all of those. You create a tree, like an AST, for example, and you try to understand what is the input from the users and where it flows into a sensitive function. In security lingo terms, that's basically called taint analysis or sink to source. Source to sink flows. And so you could run these, and these do not, the beauty of this is they basically do not require a live running applications. Like it's not dynamically, trying to send HTTP requests. It's actually like working on the code base. The second advantage there is you could find it super fast. Like theoretically, you could find it when you actually code the bad, the bad practices of insecure APIs. Because that's kind of like finding it where you actually, code, and it only needs your source code. The other way of the other methodology of finding those things is called DAST. It's basically a dynamic application security testing. And what it actually means is you do need to have an actual instance of your web app, whatever it is, like an API or a React application. And there's like this DAST application, that's the security kind of like scanner, will go ahead and try to basically fuzz test it. In terms of it will spider all the available links. It will send different, if you have an input form for a username or a first name, it will try to SQL inject it or XSS inject it. It will try fuzzing with different like strings and control characters and whatever until it finds something. It's just a little bit further down the hill. Like you actually need to have a working application. You need to have like a CI, a build environment for it. You need to basically run it, which might theoretically take a bit more time depending on how big is the application. So there's these are the two ways of doing it.
Yeah, thanks. That was a good answer. I think I have to look into this tools a little bit. Just one more from me because we don't get any from YouTube at the moment. So when it comes to React, is there like a specific set of like properties or like these attributes where to look? Because now we know that the href is dangerous. But are there more of this?
I'll pass a link that you could share if you wanted on kind of like a cheat sheet of how to find what to avoid or what to find in terms of best practices. So href is one of them. If you're doing dangerously set in or HTML, that should be obvious, but make sure that you output and code it. And it might be easier said than done, the output and coding it, because there's DOM Purify, which is well known and respected library to actually output and code strings. But it's a library at the end of the day, and it does have vulnerabilities in it. Like even if you're using that as a dependency, you have to make sure that you're on the bleeding edge all the time, right? And you do not have a version that has vulnerabilities in it. And so you might think you have actually output encoding it, but you're not doing it. So because there's a vulnerability in the library itself. So that's one of them. I think that article for those 10 best practices names some other kind of examples. Like for example, if you pass a props object as is, which is pretty common way of maybe doing some stuff in React, think of what happens there, because the underlying mechanics of React application is if I am just providing a props to an element or to a class that doesn't have any other data in it, like it's basically childless, what happens is that those props, if they have an underscore HTML and then the dangerously set inner HTML thing in it, then it will actually use that and render that into the DOM. So I do have an example for that, and feel free to kind of ping me afterwards on this. But it shows you how the very similar best practices of just passing props from one component to the other would actually come and bite you, because if you're doing it in a component that has no other children, and I can actually am able to take control of what's in those props. Like for example, an object that you read from somewhere and pass it on, that is where things could go wrong. And even if you try to make it, legit, it still kind of blows up. So that's a few of them off the top of my head, at least.
Yeah, that was a lot. I think it's one of these topics for React developers that they should know more about, because it's
definitely. Can you tell us any libraries to do that do the testing, like on CI and stuff?
I'm gonna write a couple of them here. Yes. So yeah. There's the React security linter. Let me find it. So you could just Google React security linter or something, and you'll probably just find it.
Yeah.
It's the thing is with the linters is they are very they're very rigid. So it's like a rule of like either you use like you don't use dangerous HTML or you use it. It doesn't know to say, you use dangerous exception in HTML, but you output and code it. It doesn't know this. So you have to like put the comment that says ignore this, right? The problem is it's pretty rigid, and you end up like all of the code base is then stuck like that. And then imagine that 2 months later down the road, someone actually removes the actual output encoding for some reason, like there's a junior developer or whatever, right? So like it doesn't understand that. That's why exactly, the problem is still there, and you actually like ignored it to begin with, and kind of like that's kind of how it ends up into a security vulnerability. So that's why I was like mentioning maybe with the SAST kind of approach, like Sneak has this Sneak Code, which is a plugin. You just put it in VS Code or IntelliJ, and it does the static application security testing while you actually code. So if you do some bad stuff, it will actually find them. It does support like Java and JavaScript and like different languages and different. I think it does like support React and Angular or Express, whatever you're building there on the JavaScript side of things. And so it's a smarter way basically than having like regex rules. It's a smarter way to understand the flow of things and let you know. The beauty of it is basically while you code, right? It doesn't need to run on CI or as a linter or something. It just while you code in the IDE extensions.
Nice. Are there any, like you're talking about also some that actually run your application and test these, like look for random inputs and stuff? Is there anything that you can think of that does that as well?
Yeah, definitely. So I've linked that as well, and I'll get you.
Oh, nice.
There you go. And that's the link for it. So OWASP is it's a well-known resource community, foundation for web application security. One of the projects that it has, it's called ZAP, which is short for Z Attack Proxy. What it actually does is exactly that, plus more. It's like a pretty cool thing. You spin it up, you tell it this is my remote host, and it will try to do different ways of basically, it's kind of like, it's need a proxy in between, and then it is able to then go ahead and like fuzzy test all the data in it. And so this is like a pretty common tool to use for dynamic application security testing.
Oh yeah, this looks really cool. Like if you're already spinning up your application for Cypress and a lot of stuff, might as well spin it up for security as well, I would say. Yeah.